The orientation of the waves is a property called polarization. Prior to the upgrade, radars could only send out pulses that were oriented horizontally, in other words, horizontally polarized. Today, WSR-88D radars send out pulses that are polarized in both the horizontal and vertical, which allows us to obtain vital information about the size, shape, and orientation of targets rather than just their intensity and velocity. Dual polarization yields a few additional products that can be extremely helpful, especially in severe weather situations. The first is called correlation coefficient, shortened to CC or ρHV. Correlation coefficient compares the consistency between backscattered power in the horizontal and vertical planes. In simple terms, it tells us how similar or correlated the targets are that the radar samples. Correlation coefficient is unitless and ranges from 0 to 1. If targets have similar shapes and sizes, the correlation coefficient will be close to 1, but if their shapes and sizes are quite varied, correlation coefficient will decrease.
Don't learn storm chasing alone. Go where chasers are already talking. Discord community link in description.
For example, if a storm or a portion of a storm consists of only raindrops, the associated correlation coefficient will be near 1, as all the targets are quite similar to one another. However, if a storm consists of a mix of raindrops and large hail, the correlation coefficient may decrease given reduced consistency among the targets. Correlation coefficient is also a good discriminator between meteorological and non-meteorological targets, with most non-meteorological targets registering a CC value below 0.9. The exception is large wet hail and large wet snowflakes, which typically yield CC values between 0.8 and 0.97. The next dual polarization product of note is differential reflectivity, or ZDR, which is essentially the ratio of the backscattered energy in the horizontal plane to the backscattered energy in the vertical plane. After a bit of mathematical cleanup, we get a range of possible ZDR values between positive and negative 7.9 decibels. Differential reflectivity gives us valuable insight into the orientation of targets being sampled. ZDR values near 0 mean that the backscattered energy was similar between the horizontal and vertical planes, indicating more spherical targets like small raindrops or hail. Highly positive ZDR values suggest that targets are much wider than they are tall, such as large raindrops that flatten out as they fall. The opposite is true for highly negative ZDR values. They indicate targets that are much taller than they are wide, such as falling ice crystals or elongated snowflakes. Highly negative ZDR values are quite rare in severe weather situations.
Remember to check out those links in the description below, and then watch another video.